The full solution to lab number 4. As we did before, we can find the slope, intercept form. We can find the y-intercept by using the equation negative slope times x sub 1 plus y sub 1. And that says that the y-intercept is 3, and it looks like this thing is heading up, and yes, it looks like it's probably going to be 3. Now the equation of the line from A to the mirror, well, let's use point slope form. We know it goes through A, so that part's easy. This is the same coordinates as the coordinates of our point. So how do we do that in a formula? Well, it's just equals the same thing. Hit enter. This one, the y-coordinate equals the same as the y-coordinate of the original. Now what does the slope equal? Well, the slope is the opposite reciprocal of this slope because it's perpendicular. So let's do that. Equals the opposite, negative 1 over, that's called the reciprocal of m. And if the slope is negative 2 on the red line, the green line, the slope is 1/2. So that looks like that's working. Now we need the same equation as up here to calculate b. So I'm going to show you another way to copy. I'm going to use file copy, edit copy, and then go over here and edit paste. Now you notice it still does the same thing as if we use that little box and drag, but here, since this cell was not right below it, we did not drag. Okay, so the y-intercept looks like it's 1/2, and again, that looks like it's good. So this shows the importance of having an example where you know the answer, so you can check your work as you go. Okay, so we have two lines, this line, the green line, and the red line. We want to find the intersection point, and again, we go back to lab 3 where we did all this work, and the point of intersection is at equals parentheses B1, let's call this the line 1, minus B2, close the parentheses, divided by parentheses M2 minus M1. Again, if this is not making sense to you, please take the time to look at the solutions to lab 3. And the point of intersection looks like it's at 1, which is good. Now we have an x value, we plug in the x. Let's plug that in. So let's plug it into the red line. M times x plus b, mx plus b. So there we go, we plugged that in. We plugged m times x plus b, and then hit enter. And so we have our point of intersection. And the next step is from A to B is a vector. And let's find the coordinates from A to B. So we find the vector coordinates by subtracting. We take the final point minus the beginning point, and this does go back to from A to B. And let's do the same thing here. Hey, wait a minute, we shouldn't type that again. Let's copy. It's the same thing, we subtract. So let's just drag this time I'll drag it to the right. And so it does go back to down 1, so from A to B, the components are -2, -1. So far so good. Let me drag this down a little bit so it stays with us. And the last step is, now that we know that this has a vector components of -2, -1, let's go the same distance and direction to find the image. So we need to go from B another back to down 1. So here we go. the coordinates of this is the coordinates of B, and we'll just add our vector to that. Why am I adding? Because the -2 is already baked into there. Equals this plus that. There we go. Now once again, that works, but I like to go back and check to make sure everything works. So I'm going to zoom back out a bit. And I'm just going to type in new coordinates. Let's say 7, 11, and a new line. And everything is always updating. So if you do want to check this, put this into GeoGebra or into Desmos, and you can check to see if your line does, these two lines do intersect at that new point.